Alright, welcome to the last piece that we're going to deal with in recurrent neural networks, and that's one-dimensional convolution. Yeah? One-dimensional convolution is a great alternative if you want to deal with natural language processing. We'll explain how it works, and we will also do some coding exercises. Let me just recap convolution. Yeah? Remember, in convolution we had a picture, and this picture could have 150 by 150 pixels, and this is a black and white pictures. Otherwise we would have RGB versions and the depth would be 3. So now the depth is only 1. And then we convolve that picture with what we call a filter. Here the filter is a 3 by 3 filter. Yeah? And so the filter has 9 weights. And the whole purpose of Covnets is to find the weights, or to optimize the weights of that filter and learn features. So then you have a feature map activation. Yeah? Activation means that whenever you do the convolution, image convolved with filter, you take the ReLU. As a non-linearity. And remember, afterwards we would do a Maxpooling. Maxpooling is to significantly reduce the size of the feature maps. And typically a Maxpooling layer would be of size 2. So in this case, a 2 by 2. Alright? Now a one-dimensional Covnet is pretty much the same. So what we're going to do is use the time axis as the dimension for the 1D Covnet. So basically the dimension is the temporal axis. And I've drawn here this time axis, and here you have your sequence of words. The cat jumps over the fence. Yeah? So here we could also define a filter. And actually you could have more filters here. I only have one filter, but you could have more. So here I have set 2 filters, F1, F2. The size of F1 is 2 and the size of F2 is 3. So in F1 you look at 2 words at a time. So you have this here, cat jumps. Yeah? Whereas F2 you look at 3 words at a time. And of course, if you have 2 filters, you also have 2 activation maps. Yeah? So here we're also going to do Maxpooling. But the argument will be higher. The size will be higher. Why? Well, because in this case, in a 2-dimensional case, you have 3 by 3, you have 9 parameters. If you make this a color picture, you have 3 by 3 by 3, you have 27 parameters. Whereas here, for example, if your max pool is 2, you only have 2 parameters. Yeah? So we can increase that number when we deal with 1D Covnets. And then at the end we will use a global max pool one dimension. Yeah? Whereas a max pool focuses on the image, I mean on the window, right? The global max pooling will look at the whole sentence and take the maximum vector. Yeah? So this is the main difference. Maxpooling, you only look at the window, and the window could be 2 or 3 words and gives you the max vector of these 3 words. And global maxpool looks at the total sentence and gives you the max words. That's why there is no argument when we use the global maxpool. Alright, so it's quite simple. Yeah? And if we compare 1D Covnet with RRN, it's clear that the 1D Covnet is computationally less expensive, and it actually goes very fast. The problem is that a 1D Covnet only cares about local order. Whatever happens in that window doesn't look at the global order. Yeah? And it's fast. Whereas the recurrent neural net cares about order, local and global. That's why we have the recurrent layer. Yeah? But it's slow. We've seen if we run a stack of LSTMs with recurrent dropout, it takes quite a while to process. Yeah. So this will give you an idea of what applications to use one of these for. Yeah. Sentiment analysis, for example, you're gonna look at sentiment bearing words like bad or good or fantastic or terrible, right? It doesn't matter where these words are in the sentence. Yeah, it doesn't matter. So here you should be able to use the 1D coughnet as an alternative, a faster alternative for an RNN. Here an RNN you will typically use for time series, where there is a global order that matters. But how can we profit from both? How can we be fast and care about global order? Well, if you have a long sequence, the global order will become more important. The first thing you can do is feed this sequence first to a 1D coughnet, and the 1D coughnet will break this long sequence into smaller sequences, by using the window. And then you can launch an RNN having these smaller pieces as the input. Yeah. So we will do coding exercise as well. We're gonna take the GINA data set, or the temperature or the weather data set. And we're going to use the same values for look back and delay, but the number of steps is going to be 3. That means we sample every half an hour instead of every hour.